My name is Donnison. I'm on the team that brings you MySQL.com and a number of other websites that you may or may not have visited. Work for Sun Microsystems naturally. And today we're going to talk about Memcached and how to set up, install it, and how to write your code for it. But before we go into that, a little bit about MySQL.com and where we use Memcached. Now I've kept the presentation relatively short so that there's plenty of time for questions. If you do have questions at any time, just whack your hand up or stand up and shout them out, because this is really a beginner's guide. We want to get you to understand how you can leverage Memcached for performance on your web apps or indeed any other apps that you want to use. So, as I said, questions anytime, that's fine. A little bit about MySQL.com. We get more than 70,000 downloads per day off the site, mainly of the MySQL community server, but we do have other products on that site as well. There's more than 3 million registered users the last time I looked, and more than 3 million unique visitors each month, with more than 20 million page views per month. Now, the infrastructure that I'm talking about not only delivers MySQL.com, but it also delivers the forums, blogs, solutions site, Planet MySQL, the shop, and a number of other sites. For instance, one of the main things that's used is the dev zone, where we have the documentation. Now, we provide the infrastructure for the docs team, they provide the content. So it's all on a common web platform, and it all uses common code libraries. So what is Memcached, or Memcached? It's a high-performance distributed memory object caching system, generic in nature. Well, you can read it. Basically, what Memcached is a cache. That's all it is, except that it has a few unique properties. One is that you can set it up on spare memory on servers that you have lying around, or you can set up just dedicated servers for it. You can add multiple servers to provide an extensive cache, and you can, and the way that it works is that you have a key and some data, and that's all it is. Provided that you can retrieve your data with a key or store your data with a key, you can use Memcached. Why would you use it? Well, it was originally developed by the guys at LiveJournal because they realised that they could get massive improvements in performance and massive scale out if they used something other than hitting the database every time they wanted to put, a sentence up on a web page. Rather than doing that, they found that they could in fact generate the entire page, cache that, away you go. So you get massive scale out, faster page loads, more efficient use of existing database resources, and that's what it's key to. It's minimising the number of hits on your database to improve the amount of resources that you've got. Because every time you hit the database, you've got a heap of resources that are in use. For instance, you've got a network connection to the database, you've got to do the parsing of the query, you've got to execute the query, which probably results in a number of disk accesses, and so on and so on. And you've got to get the data back, which could be a whole heap of results, and you've then got to decide how you're going to present that. And easily utilised idle computing resources. As I said, Memcached allows you to run it on multiple servers, and in fact on the MySQL.com web servers, we run it on each of the web servers. Even though we're caching database stuff and we have dedicated database servers, because of the way that our application works, we actually have spare memory resources on the web servers, but we don't have spare CPU resources on them. We don't have spare memory resources on the database servers. Most of it's all connected to the database or committed to the database. So what we need to do is to be able to shed that load across the servers that we want. And you can scale it up to dozens or even hundreds of nodes. And there's no interconnect or proprietary networking required. It just uses a standard TCP connection, and it's extensible and customizable. The key is it is really simple. And because it is simple, it can be made to do just about anything. Now, at MySQL.com, we came up with using Memcached because we had some scaling issues. And we needed to look at those. The first thing that we looked at was database replication. I'll go through that a little bit in more details so you can understand why we were having problems there. But the biggest problem that we had was this scaling issues related to database replication. We also then found that we could improve our performance on web page loads by speeding up session management. We also found that we could do things like where we needed to provide small images or even large images, we could use Memcached to provide an improvement in the handling of that, both on the display of them and also managing the upload of them. And we're still finding things to do with it. But let's look at that scaling problem. When you look at a typical web application, you start off with one or two servers and away you go. And as you start to build the number of servers that you need, or even if you scale up and build up to bigger servers, you're still going to hit some of these problems. As the load rises, we started adding web servers. Then we started to find that the database became the choke point. So, natural thing, replicate the database. We then modified the code to handle the split reads and writes, because once you replicate a database, you tend to have a write-only master and one or more read-only slaves. So what you need to do is to write your code such that they make use of that architecture. In other words, that when you're writing data, you're writing it to the master. When you're reading data, you're reading it from the slaves. But that then gives you a replication lag issue. Because what happens is when you write it to the master, the slave then has to write the same data after it's committed to the master. So there is a timing situation where you write the data to the master, it has to be committed, and then the slave picks it up in its in the bid log and writes it out to its database, and you get that lag. Now, if you have an extremely busy database server, that lag can actually extend seconds, even minutes. And in some rare cases, even hours. So you end up with replication lag issues. With MySQL.com, this is sort of the path that we went down and where we're at now, is that we started off with a single web server. That's easy. You don't have to worry about much when you have a single web server and you only have the traffic to drive that. Once you start getting more traffic, then you start having to look at solutions to handle that. So now we're sort of up to, I can't remember, I think we now have close to 24 servers on various parts of the system. We have front-end servers, we have database servers, we have reporting servers, and we have staging servers and all sorts of stuff. So it's now become a fairly complex system. And because of that, we needed to look at handling that in the most efficient way, and that's why we came to Memcached. Now, I'll give you an example of where Memcached really came into its own, and this is on the replication lag issue. When you go to MySQL.com and you sign in as a user, you can end up in the user profile page, where you can change your details and all that sort of stuff. Think of this situation. You have that user profile page. You have your code written so that you write the data changes to the master database and then you read them back from the slave. Now think of what happens when you input stuff into this form, because we're then going to redisplay that form back to you. So we take the data that you've given us, we write it to the master database, we read it from the slave, and we put it up. Now the time that it takes us to take that page and then display the next page may be shorter than the replication lag. In other words, we may be writing the data to the database, to the master database, and then when we read from the slave, it hasn't got that data written to it. all of a sudden we have users complaining because they're saying, I updated my stuff on the profile page, it came back and it didn't update it. I had to do it again. Well, they didn't actually have to do it again. It just looked like it because the data hadn't been replicated to the slave. So we end up with this replication lag issue. So how do we handle replication lag? Well, there are a couple of ways that we can do that. One is that we'll, for those sensitive pages, let's just read it from the master. Seems a logical solution because that's what the problem is that the slave hasn't got the data yet. So if we're writing stuff, let's read it straight back from the master. The only trouble with that is you've just done away with your whole reason for having replication, which is to split your reads and writes across multiple servers and to be able to scale your reads. So it doesn't scale. The other thing that we could do is, instead of writing it to the database, as well as writing it to the database, we could, remembering that MySQL.com website is actually all written in PHP, we could use PHP sessions. Anybody not know what PHP sessions are or have a problem with that term? Or session data in general? Okay, great. Is everybody awake? Yeah. Mind you, it could be the accent, and no, I'm not speaking with an accent, it's just you hearing with one, so we'll be right, we'll get there. Okay. We could write it to the PHP session, but now what we're doing is writing it to the database and writing it to classic PHP sessions, which are a file on the server somewhere. So we've now increased our file I/O. We've also increased the load time for a PHP page because the more stuff we put in the session, the more has to reload each time we load a page. And it also increases the PHP memory usage, which, if you're running on Apache, can be an issue because the Apache PHP handler, or when you're using the Apache with the PHP handler mode rather than CGI mode, it does not release that memory. So that Apache process, if you have a PHP process that takes a huge amount of memory, say it takes 100 meg of memory, and then goes away, and you have little PHP processes, you've still now got a 100 megabyte Apache process that's sitting there. Now, if you have a lot of people coming in and they keep hitting that particular page that generates that 100 megabyte Apache process, you can quickly run out of memory on your Apache server. Now, there's ways of dealing with that. That's not what this is about. But if you do have that issue and you want to talk about it, I can talk to you offline. And as a result of this, it doesn't scale. So I've told you a whole heap of things that doesn't happen. How do we do it with Memcached? Well, what we can do with replication lag is write it through Memcached to the database. Basically use Memcached as a write-through cache. We read it first from Memcached. If we have a miss on Memcached, we then go to the database. So now, going back to that situation where we had the user profile page. Go into the user profile page, we write the data to the master database, and we write it through to Memcached, which, because it's memory-based, is really fast. And we're not getting any file I/O. There's a little bit of CPU involved, but to be honest, when you look at Memcached, you can throw heaps of stuff at it, thousands and thousands of connections a minute, and you're not going to see much in the way of CPU overhead. Memory, yeah, that's what it's there for. It uses memory, but it doesn't use a lot of CPU. But getting back to the thing, we see we write the stuff to the master database, we write it to Memcached. Then when we're bringing that page up, the first thing we do is say, is this data in Memcached? Yes? Great. Grab it. Got it. There. Done. If it's not, we go and grab it from the database. Now, if we've set Memcached up so that we have the expiry date or the expiry time of that item in the cache longer than the expected replication lag, then we've just solved the replication lag issue. What we also decided to do, or one of the things that you can do, is use object orientation to get the most out of Memcached. Because again, we're sort of lucky in that the website uses PHP and we use a lot of object orientation. In fact, we're now using the Zen framework for a lot of the stuff, thanks mainly to Duke sitting over here. And that's just to get him back for putting me on his jobs. So that allows it to become a plugin. Now we'll talk a little bit about how we would make it a plugin and why that's important later on. But the other thing that we did was distribute it over as many nodes as web servers, because it's a good complement to our web servers. As I said, the web servers have a bit of spare memory available to them most of the time, and we can maximise the server usage. As I said before, we don't want to put it on the database server or on our database servers, because all of the memory that we've got on the database servers is configured for database optimization. So have I covered anything that's sort of alien or... Great. Now, Memcached is not a magic bullet. As one other presenter will keep telling you, it's just a cache. So when are those situations that you wouldn't use Memcached? Well, it's not a substitute for optimised queries. If all you're using Memcached for is because your queries are taking too long and you're too lazy to optimise them, then you are going to get no benefit out of it whatsoever. Oh, you might get a little bit, but you really need to optimise your queries first. So you look at all of the parts of your application. Memcached is an adjunct, it's not the total solution. And it's no faster than a primary key lookup, especially on InnoDB. You have pretty good primary key lookup capabilities. So what you want to do is think about, so you don't, if you're going to be doing primary key lookups, except for that implication of replication lag, if you're just doing it to cache primary key lookups, you're wasting your time. So you need to think about what data you've got, where it is, and where it's best to get it from. And there's, again, there's no point in optimising something that doesn't need it, and that's the point about primary key lookups. Memcached, not a good match. Memcached is an object cache. It doesn't give, it doesn't worry about what you put in the cache. As long as you can identify it by a key, it can go into the cache. So, and the PHP client libraries are really good with that, because they do serialization of the objects that you put in there. So you can throw any PHP object at it and get it back out the other end in a same state. And you don't want to throw resources at it, a PHP resource, because that has implications that means that you don't get it back in the same state. So you don't throw database handles at it, you throw a database result at it, for instance. So what you can do is, rather than using it just as a row cache for your database, you could use it as a page cache, where you actually create the entire page and cache that, because that has much more benefits in terms of what you're trying to achieve, which is optimising the system, getting the most performance for the least amount of resources that you're using. Wrong button. I think I know about how my laptop worked, wouldn't you, after all this time? So you need to plan your Memcached deployment. Yeah, notice that so far I haven't even talked about the beginner's guide, which is how we install it, how we write code for it. Getting there, be patient. So, what's your memory usage pattern? In other words, do you have servers that you can spare some memory on? Or are you going to need to go and buy servers that are specifically for Memcached? I suggest that in most cases, 90% of cases, you're going to find servers within your application framework that you can use Memcached on. Even if it's on the same server as the database and the same server as the application. If your application is that small that it will work that way, but can still benefit from Memcached, why not? You then need to really understand what you're going to use it for. But having said that, we're still finding things that Memcached is useful for, and we're finding ways of incorporating it further and deeper into our application framework. And that's really, really exciting stuff. Have you thought through the implications? Memcached is a cache. This has implications. Data is not guaranteed to be there when you look for it. You don't do things like loading up your entire database into Memcached, setting the expiry date to 12 months and expecting the data to be there because this makes a really cool, fast database. It doesn't. The data is not going to be there when you need it. So you need to make sure that whatever you do, you can get the data somewhere else. It's a cache. It's not a data store. The data is also retrieved on a hash key. There is no searching of keys. You either have to know the key or you're never going to find the data. And that has implications to your data. Now, they are looking at some of these issues in later versions, but to my mind, the simplicity of Memcached is one of its strengths. And I really don't care that it doesn't have searching because I don't need that. Because of all these things, do you need to actually rethink your code? Do you need to set aside time for your application to be Memcached-ized? And that's an important consideration in anything that you're doing, especially if it's on a fairly large platform or large scale. So, let's have a look at primary use cases. It's fairly obvious. I keep harping on this stuff. Where data is stored and retrieved by a single key, and where the failure to find the data is non-fatal. In other words, where you can get the data from somewhere else. Might seem obvious, but it's important to remember that it's just a cache. It's not going to be the be-all and the end-all. You're not going to store your data in there and expect it to come out the other end okay. Well, if you put the data in there and it's still there, it'll be okay. It's just that it may not be there. And where speed is required, and it mitigates that need to make your code a little bit more complex. And the code doesn't have to be all that complex. So the big questions in setting up Memcached are, how often is the data accessed? And that determines the minimum cache age requirement. And then you have, how often is the data modified? Because if you modify the data, you're going to have to modify it in the cache. So that might determine the maximum age of the cache. For instance, if you don't care, it also depends upon how much you care about the data, or how timely the data is. Do you need to see it as soon as it's changed? In our case on the replication lag, yes, we did. So we made decisions on those other two questions based upon that timeliness. If, however, we didn't care, like for instance, we're running a blog site, and we've got a blog post followed by a couple of replies. Doesn't matter if that output, the blog post and the replies, is not updated in real time. Now, if you were a Twitter, you'd probably say yes, it does matter. But if you're a live journal, you might say no, it doesn't. We can wait 5 minutes before we update that. In that case, we don't need to put the changes directly into Memcached. We can wait for the data in Memcached to simply time out before it grabs the next one. Just one way of doing it. So with our replication lag issue, just to go into a little bit more detail, we use write-through caching. We read it from Memcached and we read from Memcached basically because we've already written it to the database, and we write to Memcached as well. When we read MITs, so we don't find it in Memcached, we read from the database into Memcached. So on write, we write it to both. And we set the expiry to, yep.
So if you have read miss, does Memcached handle the redirect to database, or do you have to use code to do that?
You have to use code. Memcached is relatively simple. It doesn't have a lot of intelligence of its own. And in fact, even down to the one thing that I didn't cover, which I may as well do now, is that because it's a distributed system, you have to be able to, or your client code has to be able to say which server it's going to put this data on and which server it gets it back from. Now, luckily, all of the clients do that initial hashing to work out where it's going to put the data. And there's two styles of that. One is the standard hashing technique, which basically says how many servers have I got available, divide by 3. Sort of, well, if I've got 3 servers, divide it by 3. So whatever you write will come off the same server. And that's prepended to the key that it actually writes the data out. If a server goes away when you're using standard hashing, it has to then reshuffle stuff and move it around the server pool. Now, you might sort of think, well, hang on a minute, I've got data that was on this server that now I can't access because it's now gone. The key's no longer consistent. Isn't that going to cause me a problem? Well, no, it's going to time out and you're going to write it to another server. Is it really a problem? You've got one extra database read, but it then goes into Memcached. If you understand the limitations, works out fine, it's not a problem. Consistent hashing is another technique that you can use that allows you that the same key is used regardless of how many servers there are. So you set up your initial server pool, and it doesn't matter if the server disappears or if you add a server later on. The only problem with that is that if the server disappears, then all of the data that's on that server is going to be invalidated, and you're going to have to mark it to another server. Again, not a problem. It just means one extra or one more case miss. And with the replication lag, did that answer your question, by the way? With the replication lag, we need to set the expiry larger than the replication lag. So we set it to 90 seconds in that case. I mean, you can set it to days if you wanted to, but we want to make the most efficient use of the memory resource that we've got. So we just set it to 90 seconds. And we can build it, if our replication lag is greater than 90 seconds, we've got more of a problem than we have with Memcached. We can also build it as a database abstraction layer, and what that means is that we don't have to worry about it in our code because the abstraction layer handles it. Now another example would be page cache. Now this, rather than writing through to Memcached, tends to work the other way. What we might do is to say that the page is prepared only if we don't find it in cache. In other words, we expect to see in the cache a fully prepared page that we're going to display. Now obviously, if we already have fully prepared pages that we're going to display, what's the point in using Memcached? There's no point. So if it's static data or static pages, static HTML, there are far better ways, like the kernel HTTP, those sorts of things. Reverse proxy, Squid is a reverse proxy cache. Those sorts of ways are much better at handling static data. But for those that are dynamically generated, that you're hitting the database every time that you create a page, makes enormous sense, because all of a sudden you've gotten rid of all of that database intensive work, except for the initial time that you create the page and dump it into the cache. So for those, we can use a long expiry time based upon how often we expect that data to change. Now, if it's something like, you know, I don't know, an online shopping cart, for instance, the product information is hardly likely to change on a minute-by-minute basis. If we've configured to use Memcached and the extension is loaded, then create the object and add the servers, and then we can say, right, we're good to go on Memcached. Notice that we set the use memcache equals true flag. When we're actually using functions like the get function and the set function, the first thing that we do is check to see whether or not we have memcache available. Because I don't want to write code that has to check it each time. And I don't want to write code that has to do things like determine what the outcome is if the server that I've just put this on, somebody has switched off or killed the Memcached server. So in this situation, I can put the, in this, what are we doing? Gets. I can get the, I can get the data if I've got Memcache available. If I haven't, I just return null, because that's what would happen if the data wasn't there in Memcache. So it gives me a consistent result, regardless of whether or not the data is there or whether Memcache itself is there. And that's what I'm interested in, is consistency in the returns. Because then I can do things like create abstraction layers on our database using the Memcache wrapper. Now we have a database abstraction class that we've developed because what we do is, as I said, we split the reads and writes between master and slave. Now if you actually go back to this one here, you'll notice Memcached, the protected connect equals slave. With each of our database connections, we can choose whether or not we're going to be connecting to master or slave. So any application may have two of these set up, one for writing stuff to the master, one for reading to the slave. Not so much in the Memcache wrapper, more so in the database abstraction code itself. So with the database abstraction class, what we've done is extended that to provide Memcache support. And what that does is provides that right through Memcache before it writes to the database, reads it back, and it's primarily designed to handle those situations where replication lag is an issue. Now think about this. This basically means that instead of writing into my application, my profile application, that I have to remember that when I'm writing stuff to the user table that I need to actually store that in a cache and bring it back, I can simply say, instead of using the default MySQL DB class, I can use the MySQL DB Memcache class, which does that for me automatically. And it's really important when you're writing code to sit down and think through these sorts of issues, because you're going to write code, generally you write code once, but you're going to use it millions of times, and you tend to have to read it thousands of times when you're fixing bugs. But you write it once. Because of that, what you need to do is think through what you're doing when you're writing it. And this gives us the ability to do quick plug and play. We can actually say, oh, this particular bit is starting to have problems with replication lag. Well, let's not think about it, let's just turn on the replication lag aware database abstraction layer. Now, I spoke about earlier that we have also image caching using Memcached. And there's one other thing that we do that's rather cute as well. But the image cache utilises that Memcached, and we do it for things like the user profile has your bio and you can upload a photo. Things like sometimes we have customer quotes that have a quote and a logo. The solutions page tends to have lots of partner logos on it. Now, the big problem with logos is that you need an administrative interface that uploads those logos somewhere. You then need to be able to deploy those logos. Now, in our situation, we have, for instance, if we've got the users uploading logos, they could upload to any one of, 7 web servers. Where do we then display it? Can be an issue. So in this situation, we actually write the thing to the database and use Memcached to provide that interface so that we don't have to keep loading image data from the database back out to the user on the other servers. So we never have that problem. We also have a fallback on this one where we can actually write it down out to a standard image file on the server that's requested it. So there's two ways of doing that. Now, we've tried it both ways, and in a lot of cases we've found that it's just not worth bothering with the overhead of writing the file locally. Speaking of overheads and things like that, the other thing that we came up with was the session save handler for Zen. This allowed us to basically do away with database-backed sessions. If you think about session data, it really doesn't matter whether it's there or it's not there. If you're so concerned that your session information has to be there 100% of the time, and you're using sessions that last 12 months to so that people can log in once and stay logged in, then you're probably using the session incorrectly or haven't thought about other ways of doing it. With this, we basically don't need the session to know whether or not you're logged in or not. We only need the session for status information between pages. So we simply use Memcached, which provides us with that information. We can write the stuff to the database as well, but if the data isn't there, as long as we can get it some other way, and in this case, we basically read most of the information from the user table. If you're on the shopping cart, we may read information from the item table that we've just written to, those sorts of things. So it's a bit of a non-traditional view of sessions. So they're not designed to be permanent, they're not designed to be long duration. And all the information can be gleaned from other ways when the session dies. Because in our system, the session is not related to the logging. So in summary, how can I ever get to the end? It provides a non-persistent distributed cache, can be used for a variety of situations, and it's not a substitute for optimization at code level. And it can be used, it can provide substantial performance benefits, but remember it doesn't provide any inbuilt security. So, any questions? Do you want me to go into specifics on anything? Yes, shout out.
Do you ever have an issue where the store in Memcached succeeds, but the write to the master fails?
No, because what we tend to do is we write to the master. I know that on the slide it sort of had it the other way around, but we actually write to the master and then to Memcached. Yeah.
What happens when the cache gets full?
Then stuff gets ejected from the cache on a least recently used basis, and we get cache misses. Yeah.
We have an app that takes images off the disk and applies watermarks on them.
Yep.
So we should be able to use this to cache that because obviously those watermarks will change very often.
Exactly. Yeah.
So I don't have a problem pulling it out of cache as opposed to pulling it out, generating it, watermarking it, and then displaying it.
Exactly. Yeah. In fact, that's a perfect application for it.
Severely increased performance.
Yeah, and even if you set, depending upon how often, like how often would you have to do that? Like,
Well, it's in a catalog, so the customer...
every time somebody
Every
comes
time
to
the
it.
page loads. So on a busy site, that same page could be loaded, 5, 6, 7 times in a few minutes.
Yeah. Yeah, as you say, the stuff doesn't really change that often. So you could, even if you set that up to say, even a 10-minute cache expiry, would still give you tremendous benefits. And if you had it, say, like if you had put it to an hour or a day, because remember, it doesn't matter what the expiry is. If you make changes, in that situation, the way I'd architect it is that you make changes, you write it to the cache.
Right.
So put as long an expiry as you like, because it doesn't matter, because when you make sure that the application then says, if I can't find it in the cache, I'll do the creation and whack it in the cache. That way you're covered both ways. Doesn't matter how long the expiry thing is, and you're never going to have an issue. And you're going to see huge performance improvements. Yeah.
Is the code you showed us available anywhere?
Not really, no. Except on these slides, which you can download. One of these days I might open source something, but depends upon who my masters are at the time.
How do you manage it if you want to cache different sets of data, different amounts of time?
You can. The expiry time is based on the every time you set something into the cache, and even every time you get something, you can set the expiry date for that item. So you can set it on a per item basis. The other thing is that you provide a key, and the way that you tend to do it is, or the way that we did it, I don't know where you saw the code, we actually had a prefix within the thing. What we do is we tend to namespace stuff by putting a prefix in. So all session data has SESS underscore as the first part of the key. All image data has IMG underscore as the first part of the key. So in that way, we get the segregation without having to worry about any complex mechanisms for doing that. Yes.
Can you multiply the number of Memcached in order to increase the size of the cache into a global deployment?
Increase the number of instances of Memcached.
Yeah.
Yeah.
To increase the capacity of the cache.
Yeah. Yeah. That's the whole point of it. You can do it by putting in 512 meg per instance on 1,000 servers if you want it, or using virtualization on a couple of hundred instances if you want it.
And is there an interest to use Memcached in a cluster deployment, as typically there is no replication lag problem?
No, Memcached tends not to be a good match for cluster, because in some respects you've got that, as you said, you don't have, well, depending on what the application is that you're actually using it for. Because, for instance, if you're using cluster and then you're generating something that requires massive queries on cluster to generate it, and you can cache that work, then yeah, it does actually make sense to use it. But in terms of replication lag, no, it doesn't. Down the back of the work.
How do you handle deployments to large numbers of machines? And obviously putting Memcached, the example you showed was an employee you could put Memcached on a single machine, and presumably you have configuration on the client side that tells you where to load your cache. How do you handle it when it gets to some area where you have hundreds of machines with Memcached on them?
Basically, it doesn't really matter how many machines you've got, as long as you've got a way of doing of adding the server or getting the client to connect to the pool of servers. And that's usually just a matter of providing it with a list of server IPs to connect to. So, provided that you can manage that configuration aspect.
But I mean, that's the point. I guess that's my question. How are you guys managing the configuration aspect?
Well, as you say, we've got a relatively simple situation. So we've got, as I said, 4 or 5 servers running Memcached, so it's not a big issue for us.
So you're doing it by hand?
Yeah. Okay. If you're running hundreds, and even if you're running hundreds, it doesn't really matter because you set them up once. If you're constantly changing them, then it might make sense to put in a management overlay on that. Like, for instance, even have one of the Memcached instances as your primary instance that gives you the configuration that tells the rest of them where it is.
But you guys aren't doing that?
No. Yeah, actually, if you go to the expo hall and talk to the Memcached team there, there's in the .org pavilion section at the back, they've got a stand there, so you could actually ask the question of them if there's any intelligent way of doing that. Yeah, sorry. Oh, actually, there was one here. Yeah.
Yeah. Have you noticed any performance impacts by doing the object serialization in PHP?
In terms of Memcached?
Yeah.
No, because what we're doing is doing it on those things that would take serious amounts of times to do it any other way. So the performance benefit outweighs any serialization overhead.
Yeah, so you mentioned web servers and Memcached being very nice complement each other.
Yep.
Do you see any case of where web servers could embed Memcached and the benefits of that?
Sorry, I missed the last part of that.
Web servers will be able to embed the Memcached.
Well, yeah, you could, but yeah, I mean, it just runs as a server, as a daemon anyway. So I'm not sure that there's much benefit in embedding it in your web server. I mean, part of the benefit is that Memcached, it doesn't matter where it is, as long as you can access it. There's one over here somewhere. See? On this one.
When does it use the expiration time to clean it up? Is it on a per item basis, or does it wake up and try and clear everything?
No, it doesn't wake up and try and clear it. It's actually when it goes to find the next, the place to put your thing, it will look, if there's no items available, it will actually look for the list we use to kill off, to replace. But you'd better check me on that, and as I said. Yep.
Does Memcached have any kind of metrics interface to determine
They're building,
cache usage?
yeah, they're building that into it at the moment. There are statistics that you can get out of it now. They are improving those statistics on a daily basis. So yes, is the answer. Yep.
In your earlier command, like you are located 512, if I have 20 or 30 sites, is that enough for that instance, or I need to have more demos?
You wouldn't necessarily run more. Remember, that's per daemon, so per server. So if you've got 20 servers, you've got 20 times 512 meg in terms of your global cache. So you've got 10 gigabytes of global cache there.
What about on one server?
On one server, it depends upon how much memory you've got on that server and what sort of things you're caching. Like if you're only caching things that are 10 bytes each and you're caching them for 60 seconds, that's a lot of cache for that sort of thing. But if you're caching objects that are 10 megabytes each and you're wanting to cache them for up to an hour, then it's going to run into problems. Thank you all for coming.